We're going to solve a single loop circuit, and the circuit that is provided here includes a dependent voltage source, which we haven't yet talked about in class. So let's begin by just making this a independent voltage source, and then we'll come back and maybe solve it again with the dependent source. So we're going to, when we do a single loop problem, we have one unknown, and that unknown is the current, I. I'm going to define the current. You could define it as counterclockwise. You just need to make sure that when we talk, if you talk about a current I, you have to label its orientation. Is it going clockwise or counterclockwise? And so we will write one KVL equation. I'm going to start down here, and we're going to work around. And we're going to add up all the voltages. So I'm going to start in the bottom left, and when I encounter a negative sign, then I'm going to put a negative voltage. So we'll say minus Vx minus 12 volts. Alright, and now I don't know, I haven't labeled these, the 8 and 7 ohm resistor voltages. I'm going to label them in this manner, plus to minus. And the reason I'm going to do that is if I define it this way, I can say V8 is equal to 8 ohms times I. So I have used the passive sign convention where the current I, when it enters, if I have a positive I, it enters into the positive terminal of V8, then the VI relationship is V equals RI rather than V equals minus RI, which would be, although we could work with it, but it would be confusing and prone to error because we would probably lose the sign at some point. So we'll put plus V8 plus V7 plus 4 volts. Eventually, when you become good, comfortable with this, you'll skip some of these intermediate steps, but we're going to take them kind of one step at a time and be explicit about this. Now, let's, since we're trying to solve for I, the goal is to rewrite all unknown voltages in terms of I. So V8, we've already seen that V8 is 8 times I, and V7 is 7 ohms times I. And now we haven't talked about Vx, but if you look at Vx, Vx is actually going to be equal to minus I times 30. Minus I times 30. So I actually have minus I times 30. Or in other words, just 30I. So we can combine all these, and we'll have minus 12 plus 4 is minus 8. And then we will have I times 8 plus 7 plus 30 is equal to 0. And therefore I is equal to 8 divided by 45 amps. That's our current. Now we're asked to find the power absorbed by each element. So for the power absorbed by the 30 ohm resistor is going to be 30 ohms times I squared. And I won't do the math here. I'll just write the formula. This will be the same for the 8 ohm resistor. It'll be 8 ohms times I squared, etc. So P7, 7 ohms times I squared. What about the voltage sources? Let's start with the 4 volt. P of the 4 volt source. Now if I flows into the positive terminal of the 4 volt source, that's passive sign convention. That means that that power is interpreted as power absorbed. So I will have 4 volts, so power is V times I. So 4 volts times I. Okay, and then P of the 12 volt source. Here I'm actually, the current I is flowing into the negative terminal. So it's minus 12 volts times I. And it's clear here, if you look at the orientation of the 12 volt source, that if you, let's say I was 1 amp, positive 1 amp, that 12 volt source is supplying 1 amp. So it's actually doing work. So it's absorbing a negative power because it's actually delivering power. So that makes sense here. We have minus 12 times 8/45 watts.